Good day, everyone. Today we are going to start the chapter 1 of chemistry, that is solutions, and we're going to complete the complete chapter in 4 parts. And today we are starting with the first part 1. So, at the end of the chapter, we'll also give a quick reading to the ncert as well. So, first, let's start the chapter. So, in our daily life, we usually come across substances which are mixtures of two or more substances. So, solution is one of the most important classes of mixtures, which is homogeneous in composition and properties. So, for instance, if 1 part per million, that is 1 ppm of fluoride ions in water prevents a tooth decay, while 1.5 ppm of the same fluoride can be poisonous and can cause the tooth to become molted. So, the sodium fluoride in higher concentration is used for rat poisoning. So, in this chapter, we will try to understand what solutions are and also about the concentrations of the solute which can be expressed in liquid solution and the related terms in it. So first, what is a solution? So a solution is a homogeneous mixture of two or more substances whose composition can be varied within certain limits. So here, the homogeneous mixture means its composition and its properties are uniform throughout the mixture. So in a mixture generally we refer to as, that is, which is present relatively larger quantity, is known as a solvent. But the original definition is the physical state in which the solution exists is the same as that of the state of the solvent. So in which physical state our solution is, and then in both the components which one is in the same physical state, then that will become the solvent. And one or more components present in the solution other than the solvent which are relatively in smaller quantity is called solute. So we have to basically remember what is a solvent and what is a solution, and these both together make up a solution. Solute plus solvent will make solution. Some of the features of solution. So it is a single phase system and it will not allow a beam of light to scatter. It cannot be seen with the naked eye. It cannot be separated by filtration process. The range of the size of solute particles will be this centimeters, and the solute particles will not settle down because it is a homogeneous mixture. Think about it. That is, certain properties like density, refractive index, boiling point, and uniform as in the solution of uniform throughout or not. Are these properties uniform or not in a solution? I'll let you know the answer at the end of the video. Next, we are going to deal with the classification of solutions. So the solutions can be classified on the basis of the amount of solute, on the basis of amount of solvent, and on the basis of number of components. First, on the basis of the solute. So it can be concentrated, that means a solution in which large amount of solute is present. If we say it is diluted, then a solution in which amount of solute is very less in comparison to the amount of solvent. And on the basis of solvent, what is an aqueous solution? When a solution will be mixed up in water, while in a non-aqueous solution is when a solute is being mixed in a solvent other than water, then that is called non-aqueous solution. For this, an example could be iodine in alcohol, and for this the example would be ethanol in water. And then on the basis of number of components, binary solution is the one in which we have two components. For example, it is salt solution. And then ternary solution in which three components are present, either two solvents or one solute, or one solvent and two solutes. For example, salt, sugar and water solution. And then we can go on like quaternary, and it goes on, and depending on the number of components. So in this chapter we are only focusing on binary solutions. So next we are moving on to the concentration terms. So the concentration can be that it may be defined as the amount of solute present in a given quantity of the solution. It can be expressed either qualitatively or quantitatively. For example, qualitatively we can say that the solution is concentrated or not, although it will raise to a lot of confusions. Thus quantitative is most suitable one, and we have several methods. And first let us see the mass percentage. So the mass percentage of component in a given solution is the mass of the component per 100 grams of the solution. So the formula is mass of the component of the solution by total mass of the solution into 100. So this is the basic formula. So it is an ncert question you people can solve, and I'll let you know the answer at the end of the chapter. Moving to the next concentration term, that is the volume percentage. In the same way, volume percentage is the volume of the component per 100 parts of the volume of the solution. So a basic formula is the volume of the component by total volume of the solution into 100. So this is a very important point to be noted, that is 100 ml of 35% volume by volume solution of ethyl glycol contains 35 ml of ethyl glycol and 65 ml of water. So this is basically used as an antifreeze in cars for cooling the engine. So antifreeze lowers the freezing point of water at 255.4 Kelvin, which is minus 17.6 Celsius. So this is very important. It can be asked in your examinations. So I have provided you a question here. You can solve and know the answer at the end of this video. Next concentration term is mass by volume percentage. Formula is mass of the solute by total volume of solution into 100. So this is usually used in medicine and pharmacy, this concentration term. Moving to the next concentration term, that is parts per million, ppm. So when a solute is present in trace quantities, then the concentration is expressed in parts per million. So it may be defined as the number of parts by mass of the solute per million parts by the mass of the solution. So the formula is number of parts of the component by total number of parts of all the components of the solution into 10 to the power 6. So the concentration in parts per million can be expressed as mass to mass, volume to volume, or mass to volume. And this is used in the concentration of pollutants in the water atmosphere and the gas which is present in water. Here is a question for you. Next, moving to the next concentration term, that is mole fraction. So what is a mole fraction? It is the ratio of the moles of one component to the total number of moles of all the components present in the solution. So it is commonly represented by this symbol. So the formula is number of moles of the component by total number of moles of all the components. So here the mole fraction of a solute will be moles of the solute by total number of moles of the solution, which is represented as this, and then the mole fraction of solvent in the same way. So if we combine these both, then we will get 1. It is a very important equation to remember. It will help us solve a lot of questions. This is a question for you. It is an ncert question. Moving to the next concentration term, which is molarity. So what is molarity? It is defined as the number of moles of a solute which is present in 1 liter of solution. It is represented by capital M. So the formula is number of moles of solute by the volume of solution in liter. And it is very important to remember that it is temperature dependent. So this is a question for you. You can solve it. Moving to the next one, that is molality. It is represented by small m. This is very important to remember. Molarity is capital M. Molality is small m. So molality is defined as the number of moles of solute per kilogram of the solvent, not the solution. It is solvent. So it is represented as mole per kg, and it is independent of temperature. That is, it will not change with the change in temperature. So the basic formula is moles of solute by the mass of solvent in kg. Here is a question. It is an ncert question. So we have completed the basic concentration terms. So now let's see the questions which I have provided you. So the first question is it uniform or not? So the answer is yes, it is uniform. Moving to the next question, that is, what is the volume percent of a solution made by adding 38.2 ml of ethanol to enough water to make 250 ml. So what is provided? It is provided volume of ethanol to be 38.2 ml and the total volume of the solution, that is 250 ml. So what they asked us to find is the volume percentage. So it is very simple to find. So what is the volume percent formula? Volume of ethanol by total volume of the solution, which are both given in the question. We'll just place the values and find the answer to be 15.28%. Moving to the next question, that is, if 1 liter of a solution contains 5 ml of a certain infectant, then express its concentration in ppm. So what is provided to us? The amount of infectant, which is 5 ml. So we are converted into liters, and the amount of solution is 1 liter. So simply placing this in the formula, we can get the answer to be 5 into 10 to the power 3. Next question is calculate the mole fraction of benzene in a solution obtaining 30% by mass in carbon tetrachloride. So here the mass of benzene is provided, which is 30 grams, because the total solution is 100 grams, and that of the carbon tetrachloride will be 70 grams. So we will calculate the molar mass of benzene, which is 78 grams, and the molar mass of CCl4, which is 154 grams per mole. So then we know the given mass and the molar mass, so you can easily find the moles, which is using the formula given mass by molar mass, and we found the moles of benzene and CCl4. And then we are going to find out the mole fraction, that is moles of benzene by total moles of the solution, and then we found it out to be 0.458, and the mole fraction of CCl4, as we know that XA plus XB is equal to 1. So if we found the mole fraction of benzene, we can subtract it to us from 1, and we can find the mole fraction to be 0.542. Moving to the next question, we have to calculate the molarity of 30 ml of 0.5 molar H2SO4 diluted to 500 ml. So easy formula to remember is M1V1 is equal to M2V2. So we are provided with M1V1, which is 0.5 molar into 30 ml, and we have to find M2, and we are given that it should be of 500 ml. So we can easily find M2 to be 0.03 molar. Next question, if some lake is 1.25 gram per mole and it contains 92 grams of Na plus ions per kg of water, calculate the molality of Na plus ions in the lake. So it is provided that it is 92 grams. So it is simple that we can find the number of moles of 92 grams, that is given mass by molar mass. Molar mass of Na plus is 23, so the moles are 4 moles. So we can easily find the molality, that is number of moles of solute by mass of the solvent, which is 4 into 1 kg, which is 4 mole per kg. So I've completed the questions. Now we'll give a quick NCERT reading. Now let's read the NCERT. So in normal life, we rarely come across pure substances, and most of these are mixtures containing 2 or more pure substances. So the utility or importance of life depends on their composition. For example, the properties of brass are quite different from that of the German silver or bronze. And I've already explained you that 1 ppm of fluoride ions in water prevents tooth decay, while 1.5 will cause damage. And sodium fluoride is used as rat poison. And then in this unit we will consider mostly the liquid solutions in their formation, and it will be followed by studying the properties of solutions like vapor pressure and colligative properties. So we'll begin with the types of solutions. So solutions are the homogeneous mixtures of 2 or more than 2 components. By homogeneous mixture we mean that its composition and properties are uniform throughout the mixture, and generally the component that is present in larger quantity is known as solvent, and one or more components present in the solution other than the solvent are called solutes. So we shall consider only binary solutions in this chapter. So this is a very important table, and you all have to go through this because the types of solution are well in detail, and you can also remember the common examples. So the expressing concentration terms. So the composition of a solution can be expressed by the concentration. So we have completed the mass percent and the formula, and I have all volume percentage is also done, and volume by mass by volume percent and parts per million are also done, and mole fraction is done, and I've already told you these. And you can solve the example questions, it is very helpful. And we have completed the molarity and the molality as well, and I have provided you some questions, and there are some in-text questions here. Solve them and be ready for the next video, and we're going to start with solubility. Thank you so much for watching. We have completed part 1 of solutions, and we're going to complete the rest of the parts very soon, along with the NCERT readings and some important questions. Thank you so much.